So, hello everyone. Today we will discuss an important concept in object-oriented program, that is abstraction. So, what is abstraction? So, here abstraction is the process of hiding the implementation details and exposing only the essential features. It helps in simplifying complex systems by focusing on what an object does rather than how it does. Okay. Let's say, for example, think about a car. So when you drive, you use the steering wheel, accelerator, and brakes. You don't need to know how the engine works internally to drive the car. So the complex mechanisms are abstracted away and you interact with a simple interface. Similarly, in Python, abstraction allows us to define a class with essential functionalities while keeping the complex details hidden. So that is what abstraction is. So for example, here you can see an example. So here I'm importing a ABC from the abstract method. So here ABC is nothing but an abstract method itself. Okay. So this is a library name, that is abstract method. We are importing it. Okay. So this ABC, it is used to create the abstract classes, and abstract method is used to mark a method as must be implemented. Okay. So then in the next line, you can see that class shape ABC. So this complete thing, we call it as an abstract class. Okay. So once you import the abstract method, you need to create an abstract class. Okay. So this shape ABC is nothing but abstract class. That means it can't be used directly to create the objects. Okay, you can't use the thing to create directly to create the objects. So next here you do have a area self. Okay, so area self is there. So this area self is an abstract method which is like a blueprint. It does not do anything yet. It's just like a space holder. Okay, so then you do have a space pass again. So this pass is also a placeholder because we don't have any particular value to insert there. So that's why I have used the pass. So next here, you do have a one more step. This step we call it as a concrete class. Okay. So this is an abstract class, whereas this one is a concrete class. So now in this, I have used the square as a class name. Okay, so this square is a class name, whereas this class is my keyword. Okay, so this class is my keyword. After that, square is my class name. Okay, so then this square will inherit the properties of self, that is shape. Okay, it inherits the properties of shape. So then here I have used the init in the constructor. So when we create a square, we give it a side length for that. Cause square will be have measured with the help of side itself, right? One side, two side, third side, and fourth, right? So we will be giving side as a argument. And this side will remember the value. Okay, so that side will remember the value. So here I do have a area. So this area self is there where we provide the specific logic for calculating the area of the square. So for the formula of area of square is nothing but side into side. If we multiply side by 2 times, then that will be the area of square, right? So if I multiply the side into side, then I can find the value of area square. So then once I have created the code, I need to call the area. Okay, I need to call the area. So for that, we use SQ area. Okay, we use SQ area. So this helps to give the value. Okay, so this helps to give a side length of 4. Okay, so let's say that if one side of the value is 4 means square, all sides of the square will be same itself. Okay, so we want to find out the area of a square, so that for that you can give one value, that is 4, because in the square all 4 sides are equal, right? So in the place of square, the side length of the square is nothing but 4. Okay, so once you give the 4, then I will print the line, that is area of a square, and sq dot area. We use sq dot area to calculate and print the area of the square. So what it does means it will apply this 4 to the formula. Okay, so that will be 4 into 4, it will be 16. This should be printed in the output. So if I run the code, here you can see this. So this is my output. The area of a square is 16. So this is how we write the abstract method. So let's move on to the slide back. Okay, so that is how we write the abstract method. So then here we do have a key features of abstraction. Okay, so what are the key features for abstraction? So the first key feature is hiding complexities. So that means users only interact with what is necessary while complex logic is hidden. Okay, for example, when using a banking app, simple enter details to transfer money without knowing the backend processing. So that is how it hides the complexity. Then, simplifying the interfaces. This provides a clean and user friendly interface. For example, in Python, you do have a built in function like len. Okay, so this len will help you to return the length of a sequence, but you don't know how it will work in the backend, right? So then the third point is improved maintainability. So here separating implementation from the interface makes code easier to maintain and update. For instance, a database connection class can be modified internally without affecting the user of the class. So then our fourth point is about simplicity. So by abstracting details, we make our programs easier to understand and work with it. So that is what simplicity is. So then the flexibility. The underlying code can change without impacting the users of the class. So then reusability. Common functionalities can be placed in abstract classes and specific implementation can be provided in the child classes. So that is what reusability is. So this is the end of topic about abstraction in Python. Thank you.